In this video, we're going to talk about balanced forces and unbalanced forces. And the first thing we want to do is talk about balanced forces and what makes forces balanced, what the characteristics of this. And I guess the first idea is when the net force acting on the object is equal to 0. If you remember, force is what causes an acceleration. So if you have 0 force, you'll end up with 0 acceleration, which means this causes no change in motion. And this will come up in problems where they might talk about how it has balanced forces on it or 0 acceleration. So we have to know that 0 acceleration means no changes in motion. A simple example would be just simply standing on the earth. So here's a very simple picture of a little person. Actually, probably a big person when you look at the size of the earth relative to the person. And we know there are probably two forces acting on here. One would be the force of gravity. The other would be the earth pushing it back up. These forces are balanced because the person's just standing there. They don't move. They're basically in the same position. Now let's say we took a truck and we move a truck at a constant speed. And we're talking about changes in motion. So it doesn't mean that there's no motion. My kind of bad picture of a truck. Let's say the velocity of this truck is going that way. And I'm going to pick another color now. Again, what are our forces affecting this truck? Well, we know there's probably going to be gravity pulling it down. But then there's also the earth pushing that back up. Now, because this is moving at a constant speed, we have to think about how these forces forward and backwards will be going. We know there's going to be some frictional forces. Air resistance, rolling resistance of the tires, which means there has to be some force going forward that would be probably caused by the engine. These forces are equal. This is like putting the cruise control on and you're traveling 65 miles an hour on the highway. You have to have some force pushing it forward, because once you stop pushing forward, then these frictional forces would make the car, which in this case truck, start to slow down. Last thing we're going to do is look on forces on an incline, which can sometimes be a little bit confusing, but we're just going to kind of introduce it with this video. And we're going to say we have a box that's just sitting here on the incline, and it's at rest. It's able to sit on that incline and not move. So when we start thinking about the different forces that are involved here, again, gravity, and I'm going to call that F of G, is definitely involved. We also know that this surface, as this block is pushing against the surface, pushes back. The surface pushes back. We'll call that the normal force, but I'm just going to call that the force of the surface in this case. And what you kind of do is you look at this and say, you know what, I don't know if this would be a balanced force because they don't go in the same direction. What's holding this up here? Well, there's probably something called friction that works against the motion going this way. But what's counterbalancing there? What's creating that friction? Well, what you got to kind of do is look a little bit closer and realize that this has more parts to it than what we're seeing right now. There's some part of that that's pushing this into the plane, but there's also a part down here that would be pulling it down. This would be the part of gravity pulling it down. Well, that force here and this force here have to be equal, because those two are working in the opposite plane of each other. Or I'm sorry, the same plane, opposite direction of each other. So friction's being counterbalanced by this. I should say that it's actually the opposite. The part of gravity that's pulling this down the plane is actually counterbalanced by the frictional force, which in this case pulls it up the plane. So if we know that this is, angle theta, we can get into the geometry of this. That'd be theta too. But for now, just kind of understand that not all the force that's caused by gravity is pulling this down the plane. Some pulls it against the plane, but other parts makes it move down in that direction. So those are balanced forces when you have no motion. The opposite is unbalanced forces. And again, that's a relatively simple thing. It's when the net force does not equal 0. And the object will accelerate. So in this case, if we go back to our inclined plane example again, to kind of quickly sketch that in there. If the gravitational force pulling it down, with the component of that gravitational force, that's the gravitational force there. This is your part that's pushing against the plane. But if this part here, I'm going to call that the pulling force. If there's, let's just say, a small amount of friction, like maybe it's a very slippery surface, that would be the friction. Sorry about that, but that would be the frictional force pushing it back. If this pulling force is not as big as that frictional force, I'm going to fix this right here. Back to my red here. If that frictional force is not more than that pulling force, then this will slide down the incline. And we probably understand that. If you've gone to a playground slide, you've seen the same type of thing. One other example would be like a golf ball hitting a golf club. Here, that there's a force pushing it forward, that would be the force of the club. The golf ball pushes back on the club, but that's on a different surface because the reaction force, because of Newton's third law, is acting on an opposite object. That's a force that's equal but opposite on the golf club. The golf ball will then accelerate in that direction using good old F equals ma. And if we knew what the force of the golf club was, we knew that the mass of the golf ball was, we could figure out this acceleration, how fast it's going to move. So that's balanced forces versus unbalanced forces.